Good afternoon. Welcome and thank you for joining us today for our webinar, Tririga Performance Tuning, Tips and Tricks. Before we begin, we have a few housekeeping items we need to review. First, all attendees for this webinar will be muted. Due to time constraints, there will be no time for Q&A after our session. We have a solid 30-minute presentation planned, and we may run over that allotment. However, your questions are important to us, and we encourage you to submit them via email to sales@ekifm.com. Also, this webinar is being recorded for playback. If you do not wish to participate in a recorded webinar, please exit now. The playback of this webinar will be available on the eKIFM website and on YouTube for your playback convenience within 48 hours. This webinar is brought to you by eKIFM. eKIFM is a premier IBM business partner and a certified value-added reseller for IBM Tririga. eKIFM has achieved the Gold accreditation for deployment of Tririga. Our team includes certified Tririga developers and experts who collectively offer over 40 years experience and other Tririga solutions. For more information on our value-added services, please visit our website at ekifm.com. Our speaker today is Mr. Bill Carey. Bill is a 30-year veteran of the IT industry, including 23 years with IBM and Wipro. Specializing in infrastructure and performance of multi-tier enterprise products, Bill is a leader in the Tririga ecosystem with strong connections throughout the industry. He describes his mission to be the continued growth of Tririga and the education of the community to build upon ever-growing ROI for this powerful product. Bill is a go-to resource when you want to make your Tririga implementation a success. And now, without further ado, I'll hand you over to Bill. Bill?
Hello, everyone. This is Bill. Some of you know me. I've been around for a while, so I've crossed paths with many of you. I want to let you know how much I appreciate your interest in this session, and I'm excited to give you some tips and tricks here. So I want to start off with telling you a little bit about Tririga. I expect everybody here is here because they know about Tririga, but just to sort of set the level playing field, Tririga is a very powerful platform that supports the building of industry solutions. And Tririga has a number of prepackaged industry solutions and then the ability to develop more and customize those industry solutions. So incredibly powerful, has lots to offer, and in some cases, it can even return up to 25% of the costs that some people incur with, let's say, operations and maintenance or other parts of the business. So making sure that you use Tririga in the right way can really be a big cost savings and a driver of improved net revenues. So I'm glad that you're on with our team, and we'll go ahead and get started with this presentation. So I want to tell you a little bit about who eKIFM is. Many of the people here have been involved in Tririga since before Tririga was Tririga. This product has its roots back in the mid-90s, and some of the people here have been involved since that time. Again, it's a Gold business partner of IBM, and when I was a manager at IBM, I worked very closely with eKIFM, and now I'm very happy to be a part of the eKIFM team. eKIFM also is the creator of OTG, or on-the-go mobile. This is an important product. It's a unique mobile product that allows you to work offline. So you can download your work in the morning, go away from the network, do all your work throughout the day, come back at the end of the day and upload your work back to Tririga. And this is something that is unique in the business. It's a leader in the business, and if you have any interest in that product, you should definitely reach out to us. So before we can get started with performance, you have to understand a little bit about the architecture. Tririga is driven by metadata, and metadata is sort of a funny word, but you can think of metadata as data about data. And so to help describe that, I'll just say things like screens and business logic are typically written in code, and someone who uses the product, there's some code running in the background that a developer actually sat down and coded in Java, for example, and that business flow is not really changeable without going in and changing that logic, or that screen is not really modifiable unless you go in and make changes to the code. In the case of Tririga, we store everything in the database, absolutely everything. Screen definitions, where fields are, how long they are, business logic, if-then statements, calculations, queries, everything that you do is stored in the database in Tririga, which just makes it incredibly powerful because it means that using the tools built right into the platform, you have the ability to make changes to the business logic. And we'll talk a little bit more about that, so I want you to keep that thought. I want to talk a little bit about the pros and cons of metadata. So metadata makes Tririga very powerful. It allows business logic and the whole flow of things to be configurable. It allows you to do some look and feel stuff and to create new screens. It even allows you to generate new industry applications if you think of things that you would like to use Tririga for. So the cons, and that's what this presentation is all about, are that you must have Tririga tuned almost perfectly, or your end users will suffer. And the last thing you want is for your end users to suffer. I think anybody who's done anything in the IT business realizes that when you roll out a new product, if it doesn't work within the first couple of weeks, your users start to abandon it. And it will really cause you a lot of grief in the long run trying to get them back on board. So it's very important to roll a product out with good performance to begin with. Then as it goes on, you have to know how to do the care and feeding to keep it running and keep it delivering what your users need. So you can see that the cons are powerful, but not insurmountable, okay? I did that right, okay. So this slide is really to help you understand that although I've been in the business a long time, I'm definitely an engineer and not an artist. So I kind of just threw this slide together in 2 minutes just because I wanted to kind of make a bad joke, but also it does describe the architecture, the layout, and helps you see the flow of data. Now, it's also a mistake down at the bottom. The last item at the bottom of the page says Tririga Application Server, and that's supposed to be Tririga Database. So just blank that out and call that Tririga Database. And you can see that these 4 things above the database, these are your application servers. They're all application servers, but we name them differently because you can perform different kinds of work with them. So the application server, we typically call the one that the users connect to. The process server is something that can do background workflow tasks, things that we call synchronous workflow tasks. There's a report server that you can set up, and it offloads the report work so that the users aren't impacted by reports that are running. I say that with a caveat, by the way. And then you can set up an integration server so that if you have products that need to integrate data into Tririga, you can use that specific server to do that. You have different kinds of clients. You might have a laptop or a desktop client, and you certainly have mobile clients. So all of these things, as you look at this page, the one single point that is the key here is database. So I want you to hold on to that point also, right? That the database is is a central point to some of the work that we're going to be doing in this presentation. Okay, so back to decent looking slides. Understanding performance is a lot about understanding what people perceive. So when a user reports to you that they've got bad performance, it's very critical to understand what they're actually saying. We have it over and over again that a customer reports performance is bad, and we begin looking at the application. Right away, we got to look and see what do they mean? What's performance? And you can't really work that way because we don't even know they haven't helped us define what that means. Does it mean that something they do takes 5 seconds, but they wanted it to take 2 seconds? Or does it mean that only one thing that they do takes really long time and everything else goes fine? Or does it mean that the system sometimes crashes or goes offline? All of these are good questions that you should ask when somebody reports to you that they've got a performance problem. And typically what I like to do is drill down into it and say, when I do this, it takes this long, but I would like it to take that long. If I can get to that, I can start working on performance. And maybe if I solve that, I will solve the rest of the performance stuff also. So good thing to do is make sure you understand what you mean by performance. So you should also know that there's rarely a single cause for a problem related to performance. It's often a little bit of network, a little bit of, misconfiguration. Sometimes the user's not doing things the right way. So, you don't want to think that there's going to be a silver bullet to solving a performance problem. Identifying the bottleneck, the actual problem of performance is 90% of the solution. I mean, you can solve a technical problem once you understand what it is, but we spend most of our time looking around for what the problem is. So you should also know that probably 75% of all performance problems are related in some way or another to the database or the network. And yet, 90% of people who start working on performance problems go right to the application because the problem has been reported against Tririga, right? So, we must have a problem with Tririga, and we start looking at Tririga as being the culprit. So even if you fixed whatever you thought was wrong with Tririga, you may not see the end result of it because there's a whole bunch of other things that are in the way. And that's why it's super important that you use an organized methodology, and that's what I'm going to talk about next. So the network is at the bottom of the stack. Everything that you do is communicated either with the database server and the application server or with the end user over a network. So if there's any problems with the network, your application is going to suffer for it. There's lots of different things you should understand about the network. What happens inside the cloud is sometimes out of our control, and we need to have ways to understand that. There's different types of communication. You should know that there is a bandwidth, which is kind of like how much data you can send, and there's latency, which is how long it takes to send that data and get an acknowledgement. So there's not a lot of hard numbers around bandwidth and latency, but I'll say that we do have a number that will help you understand it, and we'll talk about that later in the presentation. So on top of the network, you've got hardware. So you can it's rare these days that people undersize hardware, but you should just know that it's important to size it properly. And there are good numbers that you can use for sizing hardware. If you have a question about that, I can probably try to give you like some guidelines or point you to IBM where you can get those guidelines. But hardware is pretty straightforward. You want to make sure you have enough processors, enough memory, and enough and high speed enough storage in order to be able to run an application. And that's really sort of the key. The important thing to remember here is virtual machines can rob some of that hardware. So you don't want to buy something that's right on the border of what you could use and then stick a VM on top of it that robs 10 to 20% of its power. Or take a server that's super, super powered and put, 20 VMs on it that use up all of its power, and so that it doesn't actually have the power to deliver. So those are all important things to remember. Operating system sits on top of hardware. It doesn't matter really if you have done everything to make the application server, the database server, and everything else run great. If the operating system has some kind of a bottleneck, you will run into a problem with that. So again, think of this as a flow, and I'll keep saying that. It's the flow from the bottom up that you want to tune, right? So, and again, I've mentioned VMs because this is kind of a critical point. Okay, so sitting on top of the operating system, you may have something like WebSphere or a database server, or whatever it is that is housing this is what we call middleware, right? So you've got your services sitting on top of the operating system, and you want to make sure that they're tuned to the best. And you'll want to keep that point because this is where the database layer is, and the database is really critical to our success. And finally, you've got the application. It's Tririga. It's sitting at the top. Now, as I said earlier, that 75% of all problems are either at the network layer on the bottom or at the database layer at the blue area underneath Tririga. It wouldn't matter how fast you made Tririga run. These things are going to prevent it from delivering the feedback to the end user, and the end user is going to still experience performance problems. So this is a really important fact for you, because you can spend a lot of time staring at Tririga trying to make it work, and you'll never see any results from it until you've made sure the entire stack is tuned. So I hope that makes sense. So with that, I want to jump right into what you can do about network. So there are different kinds of networks. There's the local area network, which is where the database server and the application server would sit. These things need to be right next to each other. I've had clients that took the database server and moved it to one data center and an application server and moved it close to the users, thinking that that would improve their performance. That's actually the worst thing that you can do for Tririga, because all of the work that really happens with Tririga is between the application server and the database server. So any introduction of even 1 millisecond of latency impacts the end user with thousands and thousands of SQL statements that go to the database. So super critical. These things have to be as close to zero latency between them as is possible. So that's one thing. Client connectivity. That's an important piece. You probably want to be as close to 50 milliseconds or better would be good. If you go over 50 milliseconds, you'll probably start to see some latency, some problems with the slowness. So it's just sort of a number, but when you start talking about worldwide implementations, it's hard to get to 50 millisecond response. So just use that as a guide. The faster you can get, the better you'll be. And then, of course, there's mobile connectivity via wireless. And you can use mobile clients in disconnected mode. That's probably going to work the best. And then you bring them to the network and sync them later. You've got some solutions and technologies for improving network throughput. You can position the servers closer geographically to your clients, but I mean both servers, right? You can do HTTP or hardware packet compression. You can use network acceleration hardware, things like Juniper or Riverbed. You can connect clients using Citrix or remote desktop. And that basically, makes us pretend that we're actually working right next to the application server when we're not. But there are limitations to what you can do with that. And you can minimize any kind of network hops. There are things that you can do. Sometimes in big companies, you can talk to the administrators and say, hey, I'd like to prioritize Tririga traffic, or I'd like to see if we can route the traffic in a way that goes through less web servers, less switches, less hubs, less hops that get from one place to the next. So those are all things that you can do to improve the network. Again, going from the bottom to the top, hardware focus. All Tririga servers are essentially the same and run the same code. So when I say Tririga server, I'm talking about those 4 servers that I showed you on that previous slide. Those are all Tririga application servers, and we're just configuring them a little bit different for each one. So you can generally get away with 4 dual-core processors. You always want at least 4 GB of memory dedicated to Tririga. The recommended is, for me at least, I would say recommended is to go to 8 GB for each Tririga server. And what that means is the server itself has to have probably 12 gig, because you're going to want 4 gig to give to the operating system, and then 8 gig to the Tririga virtual machine, right? So just keep that in mind. And I just put in 100 gigs, sort of a random number. I put that in. You don't need 100 gig, obviously, to install Tririga, but you want room for logs and backups and whatever things like that. And most storage devices come in with considerably more than 100 gigabytes these days, but I just put that in there. But you do want to think about the performance of that storage device. Again, if you're writing logs out, depending on if you set the log levels to debug or something like that, that can impact performance, and you want to make sure that your storage device runs quickly. Database servers, generally IBM recommends working with the DB vendor. We do too. It's hard for us to tell Oracle how they should size their server, or Microsoft how they should size their server. So important to get at least the basics from them, and then you can talk to us about any fine tuning that you should do to that, or what you can do to the database server to make it run best on the hardware that you have. Generally, you should be able to get away with 4 dual-core processors, 16 gigs of memory, and 100 gigabytes of very high-speed storage. And when I say very high speed, I mean as fast as you can get it to go. No kidding. This is a really key point. You want to have very high-speed server storage for the database server. Now, this is a medium-sized company. It's a dedicated database server, so you can't take this stuff for granted. You have to think about other things. If you're in an enterprise that has a DBA group and they've got a 24-core server with 100 gigs of memory and all that stuff, they may be running multiple instances for multiple different applications on that same database server. So I'm just sort of saying, like, if this was a dedicated hardware piece for one particular Tririga database, then this is what you could get away with. And then client computer, don't skimp on the client computer. It's also connecting to the network. It's also having to render screens. It's doing things in the browser. It's doing work in the browser for HTML5. So if you have a good client computer, then it's probably going to run better than if you've gone to the cheapest netbook that you can get your hands on. So on top of the hardware sits the operating system. Here you can run Tririga on 3 different kinds of operating systems: AIX, Red Hat Linux, I think maybe other Linuxes as well. I didn't think to put that in, but Windows Server also. I believe we're up to Windows Server 2016 and 17 now. These need to be tuned. AIX, I know, was specifically very finicky about the way you tune that. So if these things are not properly managed, and again, this is not something that you typically go to IBM to complain about, you would have to go to the vendor, although you'd go to IBM for AIX, right? But and actually now I think IBM owns Red Hat too, so you'd go to them for that. But generally you go to the vendor of the operating system to get the best tuning tips for that. Most of the time, I mean, for those of us here at eKIFM that focus on performance, we know how to tune that stuff, and we can find the best tuning tips for you. I mean, ultimately, we might have to go to a vendor if there was something new that we'd never run into before, but generally, we're going to know what to do. Again, we're going to talk about VMs here. A VM can steal from 10 to 20% of the power of the system, and that's if it's tuned properly. If it's not tuned properly, if you put something like vMotion in place where it's moving from one server to another, if you share memory, if you share processors, if you do that kind of thing, multiple VMs on a single server, those things all will make you suffer, and it's very, very difficult to find out the cause. So just be cautious when you start sharing resources from one thing to another, and when you set up VMs, you want to make sure you have dedicated resources. You know, don't share any of that stuff. Your middleware focus, you basically have two types of middleware, although there's plenty more. You can put things like web servers and authentication servers and things like that in the mix, but you basically have what's shipped with Tririga application servers and database servers. And so today, these are the various types that you can get. You can run WebSphere 19004. That's WebSphere Liberty, actually. And I see that I left the word Liberty out of that, but that you should think of that 19004. That's WebSphere Liberty, and that is pre-configured, very easy to install. You can install it when you install Tririga. It harkens back to the days when Tririga ran on JBoss, and so I think you'll find it to be a very happy solution. Now, we have customers who feel very strongly about running full WebSphere. That's their industry standard. That's their corporate standard, whatever. And so they do that. But I just wanted to let you know that is a lot more complex. It's much harder to manage. There's dashboards that you need to go in. There's settings that you can and set, and it's just a lot more. So you almost need a team to manage WebSphere with those skills when you have that. So quite often you're going to be happier with the WebSphere Liberty solution. Oracle WebLogic is another one. That's a third-party product. But at this point, you start moving away from a single vendor for all the tiers. And so you want to think about what that means. You would have to go to Oracle WebLogic for some of the support, and that's a paid license, whereas both WebSphere and WebSphere Liberty are free with the product. Today, the database service supported are Oracle. That's, believe it or not, IBM's preferred, even though it's preferred for Tririga, I should say. So for Tririga, Oracle is a preferred database server just because it's a very high-performing database, but it's expensive. So a lot of customers are not prepared to spend that kind of money on Oracle. DB2 actually comes free with the product, and it runs in an Oracle emulation mode. And SQL Server it performs quite well, especially for small and mid-sized companies, but it does have some limitations. Sometimes it's more likely to get record locking. It does have some field size limitations, and scalability when you start getting up to thousands and thousands of users can be a problem. So just wanted to kind of give you a highlight of the three tiers. So your Tririga application focus, this is what happens after you've done all those other layers, right? So if you had started here and you did all the work inside here and those other layers weren't right, your end users would not see anything. Right, so you want to make sure that this is your sort of last stop as you work through the stack. So you can work on workflows. Tririga workflows are the driving force behind business logic, and anybody who's designed, done any work or customization inside Tririga has seen what a workflow looks like. It's very easy to develop them. It's also very easy to write them in a not so efficient manner, right? And you can easily put loops in that cause grief and that sort of thing. So you just want to be very cautious and understand what your best practices are as you're doing that. So if you're new to Tririga, you should definitely have people who are more experienced look at the work that you're doing. You can do extended formulas in Tririga, and all the tools and the logic for the coders are built in. You can use in-memory objects. You can stop auto recalculation. You can use different types of loops and iterators, things that can be better performance. But again, these are all sort of best practices, and you have to know them. There's not like a hard rule, oh, you should always use an iterator or you should always use an in-memory object. It's not always possible. So just want you to be aware of those things. You know, there's an interesting point about extended formulas I like to share with people. Extended formulas actually go into a queue to be processed, and there's been a number of times when somebody has seen a whole lot of processing going on in the extend formula. Like they just have huge numbers of extended formulas in the queue, and they're asking, why is it taking so long? Well, let's say you imported a whole slew of leases and they had complex extended formulas associated with them. These are very hard to work on, and they take a long time to run. So if you've imported a whole bunch of them, all those extended formulas are in the queue working in the background trying to get wiped out. And if you have thousands and thousands of them, it could take some time to get through them. And then you're working along and you keep adding more stuff to the extended formula queue, and they are much more efficient, much faster extended formulas, and they might run incredibly fast. So you see, for let's say a whole day, you're looking at this extended formula queue just kind of clunking along, knocking off 10 at a time until it finally, all of a sudden it hits a threshold and it gets to those faster ones, and it knocks out thousands and thousands of them in 2 minutes. And people don't understand why. And that's why, because it's a first in, first out. And if you've run all those complex things into the extended formula queue, it has to work through all of them before it will get to the simple ones and finally work through the rest of the queue. So just thought I find that to be an interesting point. I just thought that you'd get some joy out of that. We'll talk about application performance troubleshooting. So built into the application, there are some tools. This particular tool that you're looking at the top is available in the admin console, and you can actually share the URL for this with your end users if you want to see what kind of throughput that end user is getting. So this is a really good first stop, actually. You can just see if the user is getting good performance. So when they click on this and this comes back with 12 KB, as you see here, you can be assured that that user really is suffering because the expected user throughput should be 229K. So 12 is Tririga is just not going to really function well at all in those conditions. So just wanted you to, that's a really good point for you to go and look at if you're running into problems. Again, I think these tools actually became available in 3.5, so some people may not be aware of them yet. There's also, on the IBM site, there's these throughput calculators for the database. And each one of them for DB2, Oracle, and SQL Server, you have their own queries. And you can run these queries and it will tell you what the throughput is, and you plug those into the database and it compares what your results were to what IBM's recommended results are. And if you start seeing that you are substantially below IBM's, then you know that your point of contention is probably the database, and there's some tuning that needs to be done there. And then you've got a performance analyzer. The performance analyzer is sort of like a workflow analyzer. It highlights long-running workflows and queries, and it's a good guide to get you going. I'll tell you that there is another way to use the same performance logs that this thing depends on, and you can do that in spreadsheets. It's a very sort of complex processing. You have to understand what you're looking at. It's one of the offerings that eKIFM can give you, that you go through this process and you can analyze and see, okay, where is the main focus? What's my big problem with the application? So this is just all about tuning the application. You should know that Tririga has a number of different logs. You've got a server log. That's typically the one that everybody thinks of when we say, send us a log. But there actually are a number of other logs. There's the performance log. You need to turn this on and capture for a period of time and then turn it back off. You don't want to leave that running all the time because it captures too much data. You've got a workflow instance logging. Now, people don't really understand what this is. It's very specific to looking at a particular workflow and trying to solve a problem with it, a flow problem with it. You should never, ever turn on workflow instance logging and leave it on. You've got to be able to hone things down to when I do this, I have a problem, so that you can turn on workflow instance logging, run it while you do the things that you're having a problem with, and then turn it off. Now, first of all, you should always only do that in a development or test environment. You would never want to do that in production. And if you've got an exact replica in your test or development environment, then you should be able to replicate the same behavior in both of those that you would see in production. So at any rate, what this does is every step, everything, every single process that happens in the workflow gets logged into the database, not into a file on the operating system. It gets logged into the database. And what did I tell you? The database is the place where it really gets hammered, right? So if anything that's being done to the database that's using up its resources is hurting everything else that database is doing. You can fill that table up really fast with lots of stuff that's being done. And then the database may even crash because you filled it up with too much data. And then there is a cleanup agent that can be used to clean up that stuff. But I've had people turn on instance logging and turn off the cleanup agent at the same time. And then they've just got, weeks or months of data out there that is slowing them down. So this is a really important point. Stay away from instance logging unless you absolutely need it for a specific task. Then you've got application server logging. Things like WebSphere will generate their own logs, and the system out log would be an example of something from WebSphere. You've got database platform logging, so Oracle, SQL Server, DB2, they all generate their own logs. You've got database reports like Oracle's AWR that you can look at to see where the database is suffering. And for Java, you've got JVM heap dumps that you can see what's using up memory. So all of these are logs that can be used to help identify problems within the system. And, if you have the knowledge to use this stuff, that's great. If you don't, you might want to call a professional. So making sure that you save data for too long. This is a good point, right? And make sure things like how many sessions you're keeping, how much history you're keeping, and always, always, always run cleanup agent. Every day run cleanup agent so that it can get rid of the deleted stuff. And then it's important to be aware of external factors. If you're running database backups during business hours, that will probably impact your end users. Cleanup agent during business hours, same thing. Integration runtimes, reporting, network usage, all of these things that might cause a hiccup for an hour a day or something like that, and people can't figure out why Tririga slows down at 3 o'clock every afternoon. Those are the kinds of things that you look at. So here's your takeaways. Tuning Tririga without a methodology is going to give you very limited success, if any at all. So you've got to start with this methodology that starts from the bottom and works up. You need to understand the root cause of the performance issues, and that requires a methodology. End-to-end stack tuning is a skill requiring a wide breadth of knowledge. So you've got to know about networks and hardware, operating systems, middleware, and the application itself. I mean, this is it's the dream team to find that. Your big hitters are network, database, and application. These are all places that you can find solutions. And inside the application, there's really hundreds of performance impact points. And so you just want to get people who know what they're talking about, I think. So what can you do? Well, you can go into a performance tuning effort as a project. So here's what you would want to be sure you understood. What's attainable, understand what the user's perception is, identify all the resources in your organization, ensure all the knowledge centers are educated on Tririga, because you can't just take a DBA who doesn't understand how Tririga works. They will come back and say, oh, my database runs fine. They don't understand how important the work that Tririga is doing, and they may not know the special tuning tips for Tririga. You want to schedule the project using performance tuning methodology that we've described here. You want to take baselines before and after each change to gauge success of the actions. And you want to work on each layer independently to identify key root causes. Or you could save a lot of time and money and a lot of risk by calling professionals who do this every day. And that's who you can call us at eKIFM, and we will help you. So that's where we end the presentation. I hope I didn't go over too far. I know I went over by 15 minutes on yesterday's practice session, so let's see how we did today. I hope you will send questions to sales@ekifm.com, and we'll have an opportunity to answer those. And I'm really pleased that you all joined, and I'm looking forward to talking with you. Thank you, everyone.